Hello friends, I am Pratima. I welcome you all to my channel. I thank all the subscribers for subscribing. Today's question is from JEE Main based on definite integral. Let's solve the question how to evaluate 0 to 1 integral x cot inverse 1 minus x plus x power 4 with respect to x. The options are given as pi by 4 minus half log 2, pi by 2 minus log 2, pi by 2 minus half log 2, and pi by 4 minus log 2. So first I'm converting this cot inverse to tan inverse x. We know that cot inverse x is same as your tan inverse 1 over x. So I'll apply this one. So 0 to 1 x cot inverse x square plus x power 4 is in cot inverse, tan inverse, it will be tan inverse 1 minus x square plus x to the power 4. In the next step, I'll convert this into, split into two terms. How it is? So this equals to 0 to 1 x into tan inverse. It will be your x 1 I'll convert into x square minus x square minus 1. Denominator I'll arrange in this way, minus x square into x square minus 1. Next I'll apply the formula tan inverse a minus b. This will be plus only. 1 plus ab is nothing but your tan inverse a minus tan inverse b. So x square will be a and x square minus 1 will be b. So this will be split into two terms. One is tan inverse x square is tan inverse x square minus 1. Next step, let me take x square as t. Shading, I'll get twice x dx equals to dt. Here I have x dx only, so it will be half dt. I have x, not 2x, so this will be half dt. The integral will become, and about this limit it will be same because I have taken x square as t, so 0 square is 0 and 1 square is 1. So this will be tan inverse t first term, second term will be tan inverse t minus 1, and whole it will be half dt, so half I can take outside, half dt. The first one is tan inverse t, okay. This again I am applying the definite integral properties. What's it? 0 to a f of x dx equals to 0 to a f of a minus x dx. So in place of t, if I put here, it will be 1 minus t, 1 is a here, then it will be negative tan inverse t. So I am writing again, applying this, it will be half 0 to 1 tan inverse t dt minus half 0 to 1, it will apply 1 minus t, then 1 cancel, it will be negative t. Also will be half 0 to 1 tan inverse t dt and one will be plus half 0 to 1 tan inverse t dt. So I'll get 1 0 to 1 tan inverse t dt. Now tan inverse t, for integration of tan inverse t, I'll take your tan inverse t as theta, and t equals to tan theta, and sec square theta d theta equals to dt. So replacing again for limit, t was 0, so tan theta is 0, so theta equals to 1, lower limit is 0, not 1. Theta equals to tan theta equals to 1, so theta equals to pi by 4. So pi by 4 is the upper limit. So this is same as 0 to pi by 4 theta into sec square theta, sec square theta. Then we will apply by parts. Theta into sec square theta integration is tan theta from 0 to pi by 4. Your theta differentiation is 1, so it will be only tan theta integration 0 to pi by 4 tan theta integration. I applied by parts. Theta into integration of sec square theta minus derivative of theta, that is 1, and this tan theta again integration. So evaluating the first one, it will be pi by 4, and tan pi by 4 is 1, minus tan theta integration is log sec theta by 4. So I am getting pi by 4 minus log sec pi by 4 minus log sec 0, that is 0. It will be pi by 4 minus, and then your sec pi by 4 equals to root 2, or is this answer? The answer is on 2, so we have to convert this root 2 in term of 2, so it will be pi by 4 minus half ln 2, yeah, log 2. So let's see which one is the answer. Pi by 4 minus log 2, 4th is the answer. Thank you for watching.